In a recurrence relation, we find the next term using the previous term or terms. So there's a rule of how to get from the one term to the next term. So this one says un plus 1 equals 2 times un take away 1. So if we want to find the second term, find the next term, the second term is 2 times the first term and then take away 1. To find the third term, it'll be 2 times the second term and then take away 1. So to find the next term, you times your current term by 2 and then take away 1. And you keep doing that to find the next term. So we want the first 4 terms, and we're starting with a first term of 2. So the second term is 2 2's, take away 1. 4 take away 1 is 3. To find the third term, the second term's 3, so it's going to be 2 times the second term. 2 3's take away 1. 6 take away 1 is 5. And to find the fourth term, it's 2 times 5 take away 1, which is 9. So the first 4 terms are 2, 3, 5, and 9. Okay, one for you to try. See if you can find the first 4 terms of this recurrence relation. So to find the next term, we do 2 times the current term. So we're starting with 1. So the second term is 2 1's, which is 2. The third term will be 2 times the second term. 2 2's are 4. And the fourth term is 2 4's, which is 8. So 1, 2, 4, 8. A sequence A1, A2, A3 is defined by A1, the first term, is 2, and the next term is the current term times 2 times the current term, take away p, which is some constant. Given that the third term is 114, find the value of p. So we can say the second term is the first term, which is 2, times 2 lots of the first term, 2 2's, take away p. So 2 times 4 take away p, or 8 minus 2p. Then we can say the third term, which we know is 114, is equal to the last term, which was 8 minus 2p, times 2 lots of 8 minus 2p, 2 times 8 minus 2p, minus another p. So simplifying that, 2 8's are 16, 2 negative 2p's and negative 4p, and we're going to take away another p. So we've got 8 minus 2p times 16 minus 5p. Let's expand these brackets. So 8 16's, that's 128. 8 times negative 5p, negative 40p. Negative 2p times 16, negative 32p. And negative 2p times negative 5p, positive 10p squared. Let's make it equal to 0, because it's a quadratic. So we have 10p squared minus 72p plus 14. And we'll just type it into the calculator. Let the calculator solve the quadratic. So we have 10p squareds minus 72p's plus 14. And we get 7 or 1/5. 7 or 1/5. one for you to try. Give it a go. A sequence A1, A2, A3 is defined by A1, the first term is K, AN plus 1, so the next term is 5 times the current term, take away 2. Given that A3 is 88, find the value of K. So A1 is K. The second term is 5 times K, take away 2. And the third term, which is 88, is 5 times 5K minus 2, take away 2. So 88 is 25K minus 10 minus 2. 88 is 25K minus 12, plus 12 to both sides. So 25K is equal to 100. K must be 4. So the first term was 4. The second term was 5 fours, 20, take away 2, which is 18. And then the third term was 5 18s, which is 90, take away 2, 88. Is the sequence increasing, decreasing, or periodic? So it's increasing if the next term is always bigger than the previous term. It's decreasing if the next term is always smaller than the previous term. And it's periodic if it follows a pattern. So it's a repeating pattern. The first one, UN, is 2n plus 5. So it's a arithmetic sequence, and it's got a common difference of 2. So it's going 7, 9, 11, 13, and so on. So it's increasing. It's always going up. The next one. So the next term is 5, take away the previous term, starting with 2. So the second term is 5, take away 2, which is 3. Then we have 5 take away 3, which is 2. And then we'll have 5 take away 2, which is 3. So we can say it's periodic. It goes 2, 3, 2, 3, 2, 3, 2, 3. So it's got a period of 2. There's 2 unique terms before it repeats again. So it's got a period of 2. And the last one, 0.5 to the power of n. So we start with a half, and then we get a quarter, an eighth, a 16th. So it's decreasing. Every term is less than the previous term. So it's a decreasing sequence. 3 for you to try. Give it a go. So the first one, arithmetic, common difference of -3. It's decreasing. It's going down by 3 each time. The second one, -1 to the power of n. So it's going to be -1, then 1, then -1, then 1, then -1, then 1. So it's periodic. And it's got a period of 2 again. You can say it's periodic with order 2. And the last one, sine 90 n degrees. So it's going to be sine 90, sine 180, sine 270, sine 360. And then the sine graph repeats every 360 degrees. So it's going to be periodic. And it's got an order of 4 this time. So the sine graph is this one. So it's going to be 1, 0, -1, 0, and then repeat 1, 0, -1, 0. So it's a periodic order 4.